Hi friends, welcome to On Click Gyan. In this video together we will learn about Nobel Prize in Physics 2025 and a revolutionary mind-bending discovery. But if I told you that in the world of quantum physics a particle can walk straight through a wall, no tweaks, no crack, just through. It sounds impossible, yet it happens. And this year's Nobel Prize in Physics was awarded to three scientists who proved that this strange, invisible magic can happen, not just one particle but to millions of them moving together. Welcome to the quantum world, a place where the rules of reality bend. Here, tiny particles don't follow the rules we live by. They can exist in many states at once, appear, disappear, and even pass through barriers that should stop them completely. This phenomena has a name, called quantum tunneling. The story begins in 1928. Physicist George Gamow noticed that some heavy atomic nuclei could somehow break apart. Even though they didn't have enough energy to escape, they simply tunneled out. That insights changed nuclear physics forever. It explained why radioactive atoms decay and gave birth to the concept of half-life. But a haunting question remained. Could tunneling happen not just inside a single atom but in the world we can actually measure? Decades later, scientists found a clue in an extraordinary material. A superconductor. When cooled close to absolute zero, electrons in these materials stop acting like individuals. They pair up, dancing in perfect rhythm. These pairs are called Cooper's pair, and together they move without any resistance, as if the entire material becomes one giant unified particle. Now imagine joining two such superconductors with a whisper-thin layer that doesn't conduct electricity. That's called a Josephson junction. It was first predicted by Josephson, who won the Nobel Prize in 1973. This tiny bridge became the key to unlocking one of the biggest mysteries in modern physics. At the University of California, Berkeley, in the mid-1980s, three scientists, John Clarke, Michel Devoret, and John Martinis, dared to push this mystery to its limit. They built a special electrical circuit made of two superconductors separated by that thin layer, a Josephson junction. Their goal? To catch macroscopic quantum tunneling in action, a leap through the barrier by not one but millions of Cooper pairs moving as one. They fed a tiny current through the circuit and watched. At first nothing, zero voltage, silence, but then impossible happened. Suddenly the entire system tunneled out of that state, breaking free, and a measurable voltage appeared. They had just seen a macroscopic quantum leap. When they exposed the system to microwaves, it absorbed energy in quantized steps, jumping between distinct energy levels, exactly like atoms do. It was the clearest proof yet that something built from billions of particles could still obey the rules of quantum mechanics. Theorist Anthony Leggett, who had long studied these ideas, compared their discovery to Schrodinger's cat, the famous thought experiment where a cat can be both alive and dead until observed. Except now, it wasn't a thought experiment, it was real, a quantum system large enough to measure, behaving as one wave function, a glimpse of quantum mechanics stretching into the visible world. Years later, John Martinis would take this idea even further, using these superconducting circuits as quantum bits or qubits, the very foundation of today's quantum computers, from observing the strange dance of Cooper's pair to building the machines that may one day outthink classical computers. This journey began with tunneling. So next time you hit a wall in life, remember, in the quantum world, even walls aren't the end. Sometimes the universe finds a tunnel through. Thanks for watching this video. Like and subscribe on Click Gyan for more such informative videos.